let me invite Professor Rahul Atalage, who had been a past president of SLEMA as well, to give an introduction to the undergraduate research awards program, which will be launched by SLEMA. This essentially to encourage research in energy research in the country. So a brief introduction, and then we continue with the session. Over to you, Professor Atalage.
Thank you, Harsha. Hope you can hear me. You can confirm?
Yes, loud and clear.
Yes, sir.
Yes, thank you. Very good morning to all of you. Session chair, distinguished speakers, president of SLEMA, board members, esteemed sponsors, undergraduate project groups, all dignitaries from the higher education institutes, distinguished participants, annual sessions committee. As the chair of the annual session, within the annual session, the annual awards of most outstanding undergraduate energy research, I would like to very warmly welcome all of you to this inaugural award ceremony in this year's 2022, conducted within the annual sessions of SLEMA 2022. It is my pleasant duty to commence the proceeding with a brief introduction to the process. SLEMA established this annual awards scheme with the aim of recognizing and stimulating the research at undergraduate level, those who are engaged in the domain of energy in all higher education institutes in Sri Lanka, and scoped towards carrying out research during the last 2 years. The scheme also envisaged to entertain submissions highlighting their research work from any faculty, meaning that it can be faculty of engineering, science, technology, arts and humanities, business, agriculture, etc., engage with their final year research work related to energy in the domains such as renewable energy, energy efficiency, energy management, energy policy, economics, technology, energy poverty, and energy sustainability. The selection of winners in this competition is based on merit, and research carried out by the undergraduates in our higher education institutes were requested to make their submissions to the sessions committee, and the sessions committee established criteria quite rigorous and comprehensive, and employed, requested, invited eminent panel of judges from our university system and the industries. And accordingly, the winner and the two runners-up were selected, and the committee decided to award cash prizes for this. And the winner and the two runners-up and the next 12 outstanding research projects will also be recognized and issued and given with merit certificates. The award winners have been selected based on their scores through the evaluation process, based on their submissions made, and the sessions committee received 31 submissions for this year, the inaugural session, covering 15 faculties from 11 higher education institutes. So that's a remarkable, successful achievement as far as the annual awards committee is concerned. I am happy to inform that the submissions were very diverse and of very high quality from the perspective of undergraduate research work that we see in our higher education institute systems. With that brief introduction of the process, now I invite you to witness the presentations of the first 3 winners, but of course not in the selected order. And I invite you to witness them, and the deliberations will take place of the winners subsequently. Over to you, Mikma.
Ladies and gentlemen,
Yeah, now okay.
Current situation in Sri Lanka, we have been facing more than 2 or 3 hour power cut. Why? Why is that? Sometimes you may be saying, because we don't have dollars. That's the reason for that. But if you answer like this, I say no. That answer is totally incorrect. I will explain. because in that moment you not agree with me, you may be in the distrustful situation, but wait, after my presentation you will stand by my side. Good morning everyone, my name is Swanti Naomi and today I am going to present my final year project presentation. What it is, determination of the wind power penetration potential for Sri Lanka power system. Here wind power has a plenty of advantages, as well as Sri Lanka has excellent wind power resources. But why we should determine this wind penetration level? Because due to variable nature and less inertia, we cannot use wind machine as a synchronous machine. Because variable nature and less inertia are highly affected to the system frequency. Therefore, we should have a clear idea about this wind penetration level for assure reliable power supply. But when I was starting this project, Ceylon Electricity Board had not properly analyzed this wind penetration level. Therefore, I choose this challenge as my final year project. Therefore, my project aim is investigation of wind power penetration potential for Sri Lanka power system for 2021 and 25. There are several objectives. First one is study the existing power system network. Second one is study the PSSC software and the steady state and dynamic condition. Third one, validate the existing transmission model in PSSC. Fourth one is study the discrete-wise wind energy resource potential. Fifth one, create generation maintenance schedule for 2021 and 25. Sixth one, create wind ramp and write Python code to represent wind intermittency. And finally, establish wind power penetration potential for 2021 and 25. Here, these are my this is my methodology. I have followed the three analysis: load flow analysis, frequency stability analysis, and transient stability analysis. Okay, I have categorized my result in 4 parts. I will explain one by one. First one is model validation. Here, I did model validation because I wanted to confirm the accuracy of my results. Second one is Python code for wind ramp. This is written by myself to represent the wind intermittency. Here, these are the summarized frequency stability results for base load in 2021. This is the transient stability results for base load in 2021. Now, let's move to night peak condition. Here, this is the summarized frequency stability results for night peak in 2021. And this is the transient stability analysis for night peak in 2021. Now, let's move to our 2025 result. Here, these are the summarized frequency stability results for base load in 2021. And this is transient stability results for base load in 2025. Final one is night peak condition. Here, this is the frequency stability results for night peak in 2025. And finally, transient stability analysis for night peak in 2025. Okay. Now let's move to my conclusion part. Due to above graph, these are the summarized results. Second column represents the wind penetration level for base load condition, and third column represents the wind penetration level for night peak condition, and final column represents the curtailment wind power for 2021 and 25. This is my fourth analysis part: potential areas and capacities for future wind integration beyond 2025. Okay, now let's move to my more sophisticated point. This project is a totally environmental and financial and socially attractive project. I'm not going to explain about environmental side because this is wind plant. You know about these things. I will explain about financial and social side. Here, second column represents the wind absorption level as stated by Ceylon Electricity Board in long-term generation expansion planning. These are according to the CEB values. Last column represents the wind absorption level as stated by my research study. Here, all the results are verified and confirmed by the transmission planning branch in Ceylon Electricity Board. So these results are 100% correct. Here, as example, for 2021, CEB proposed wind level is 124 megawatt, but actually we can get 540 megawatt. Here, see the differences, ladies and gentlemen. So now you can see the difference between two values. So what's the mean of this value? The mean is we are wasting that much of energy. We are wasting 460 megawatt, that much of energy. Otherwise, we are get this kind of energy, this much of energy from diesel or from coal. So that's why if we have any clear idea about these results, as this wind penetration results, if we have any clear idea about these values, we could have issued a license for wind developers. Then we could add more free energy to our national system. That's why I was saying this is not a dollar problem. We are not deserving for this much of power cut. These research, but I should say these researchers are not enough. We should take a necessary step for these kind of things, because all countries are running with renewable energy, but we are waiting. So these are the things I wanted to share with you, ladies and gentlemen. Thank you very much.
So our research is computational fluid dynamic simulation of Hull reservoir wave energy device, and our research team is as given below. So I am Dialvis, and the rest of the team is De Silva, Gunawardana and Yong Holi, and we have been coming from 2 institutions as given in this introduction slide. So moving on to the device. So we have introduced the Hull reservoir wave energy device, and we are a floating type wave energy converter consisting of a flap and a hull is moved onto the seabed, and what happens is when the wave moves, so due to the rocking motion, energy is generated. This is a new concept of the hybrid new concept. Sorry. So the modifications, this has been derived from a previous study, and there are modifications too. So we have replaced the pendulum using a flap, and we have also included the internal fluid in the hull. So then the device was initially introduced by using this research paper, and all the physics of this device have been discussed mainly in this paper, but in this paper the internal fluid of the hull hasn't been included. So we have studied this device under different configurations by changing the water level inside the hull. So these are some arbitrary configurations that we came up with. Then deviating from the conventional approach of study, so rather than including this whole simulation to one complete simulation, so we have divided this into 2 parts. So first part is where we have considered the hydrodynamic analysis using ANSYS Aqua, and then the CFD analysis is done for the internal water dynamics as shown in the red. So there are several advantages of this approach as given below. Then this is the schematic diagram of the approach. So this was done by using 2 softwares, ANSYS Aqua and ANSYS Fluent. These are the modeling details. So most of these modeling details are derived from the initial paper, and we have incorporated these details to suit according to our model. Modeling in Fluent was done actually using a multi-phase model. So because we have considered the internal dependence of the water level inside the hull, so we have used the volume of fluid method to divide the phases into water and air, and also by this studying the equations, we have used the K epsilon viscosity model. So this is the theoretical background to find the instantaneous power absorbed by the device, and also the root mean square power at the hinge joint. So these are essential in calculating the efficiency. So these are actually the Fluent results, and we were able to find the drag and the moment at the joint, and it showed the variations as this, and also the turbulent kinetic energy dissipation for the 4 cases were found like this. So the first case is not shown in Fluent because there is no internal volume, and So we also did, as we used a new approach, we did initially a validation of the method. So we got the HRWEC and our reservoir energy converter and simulated it in ALSYS Aqua, and we actually used those results to compare with the reference pendulum wave energy converter, and we obtained a similar comparison suggesting that our approach was correct. And the capture factors were compared for the 4 studies, for the 4 cases. As you all can see, for the case 3, where 0.74 internal water height was used, so there was a large uh, capture factor producing a large amount of energy, and also you can see that the this high capture factor area was spread for a large range of damping coefficients, but in the initial 2 cases they were obtained for only a small range of damping coefficients. So the conclusions was that the chosen method was approved as an appropriate method for analysis, and also the drag forces in the device tend to increase with wetted surface while moments show contrasting behavior. And according to the turbulent energy dissipation graphs, we noted that the dissipation decreases with the wetted surface, and the internal water height of 0.7 more meters, which was case 3, produced the highest capture factor, and which was the highest efficiency. And these are the main conclusions that we were able to come across. So that is our research. Thank you.
Hello, I'm Sachini Senadira from the Department of Chemical and Process Engineering at University of Muratua. We conducted our undergraduate research on torrefaction of gliricidia and rubber wood for energy applications under the supervision of Dr. Dulika Gunaratna. One of the Sustainable Development Goals emphasized by the United Nations is to take action to combat climate change, and carbon dioxide as the major component of greenhouse gases has been proven as a significant contributor to global climate change leading to global warming. It is revealed that the combustion of fossil fuels in power plants is responsible for around one-third of global CO2 emissions. Biomass is a renewable energy source used all over the world. Scientific studies suggest that using pre-treated biomass rather than using raw biomass provides substantial economic and environmental benefits for a wide array of fields including agriculture, biofuel production, building construction, and pollutants removal. Torrefaction is a pretreatment method used to produce energy-densified solid which is known as biochar. The process is conducted at a temperature range of 200 degrees Celsius to 300 degrees Celsius in an inert environment. Our study analyzes the feasibility of using torrefied biochar for energy applications. The focus of this study is on the analysis of torrefaction performance of 2 woody biomass types, gliricidia and rubber wood, which are commonly found in Sri Lanka. Although they are used in large-scale industrial power generation applications, studies on the torrefaction behavior of gliricidia and rubber wood are very limited. As a result, these 2 types of woody biomass types are considered in our study. For the experimentations, a locally fabricated stainless steel horizontal batch reactor with a nickel-chrome heating coil insulated by porcelain accompanied by K-wool was used. To identify the thermal decomposition behavior, first we performed the thermogravimetric analysis for raw gliricidia and rubber wood. Then, based on the TGA results, suitable temperatures were selected for the experimentations. Accordingly, torrefaction temperatures were set at 250 degrees Celsius, 275 degrees Celsius, and 300 degrees Celsius, and also the residence times at 30 minutes, 45 minutes, and 60 minutes. Pressure was maintained at atmospheric pressure while continuously feeding nitrogen gas to maintain an inert atmosphere and to maintain a constant temperature. The heating rate was maintained at 10 degrees Celsius per minute by a temperature controlling system. For biomass characterization, we conducted proximate analysis of torrefied biomass with standard test methods. And we conducted an ultimate analysis to calculate the elemental composition. The calorific value of torrefied biomass was determined accordingly. Furthermore, we performed a FTIR analysis to identify the functional groups associated with the torrefaction process. After obtaining the proximate and ultimate analysis results, we calculated the energy yield and the energy mass co-benefit index. The key findings of our research are as follows. Based on our results, we observed a reduction in mass yield, volatile matter, moisture content, oxygen and hydrogen percentage with the increase of torrefaction severity, while an increment was observed in fixed carbon, ash content, carbon percentage and higher heating values. On average, a mass loss of 12% for rubber wood and 18% mass loss for glycidia was observed. It can be concluded that the higher residence time and higher temperature results in better energy mass co-benefit. We hope our research findings will benefit for the whole society, and in essence, torrefied biomass can be used as a co-firing agent in coal power plants, resulting in emission reduction and environmental and economic feasibility. With improved combustion processes, industries with biomass boilers and furnaces can also benefit from torrefied biomass. Moreover, with the successful application, 100% renewable energy, carbon neutrality, and circular economic concepts can be achieved via the use of torrefied biomass in the energy generation sector. Thank you very much for listening to our presentation and this opportunity to present during the Sri Lanka Energy Managers Association annual sessions.
Now it's the moment to declare the award winners and to do the presentation of awards.
Sri Lanka Energy Managers Association Annual Awards for the Most Outstanding Undergraduate Energy Research 2022. Silver Awards for the third place, sponsored by Fair Energy Developers Private Limited, presented to S.S. Senadira, S.W. Abesirivardhana, and U.W.A. Devaraja from Faculty of Engineering, University of Moratuwa. Outstanding Undergraduate Energy Research 2022 Gold Award for the second place, sponsored by Lanka PLC, presented to M.D.R. Naomi from Faculty of Engineering, Open University of Sri Lanka. The most awaited movement, Outstanding Undergraduate Energy Research 2022 Platinum Awards for the first place, sponsored by USA, presented to VAU the Alvis and Mr. APK the Silva from Faculty of Engineering, University of Peradeniya.
Okay, that was the presentation of awards. On behalf of the awards committee and SLEMA, I would like to indicate that all 31 submissions were of very high quality and very competitive. But in this particular year, the top 3 ranking presentations and submissions were outstanding. We would extend our heartiest congratulations to the winners and also to all research project groups who submitted their research project reports. An event of this nature is not possible if not for many contributors. Our sincere thanks from SLEMA and the organizing committee would extend to our platinum sponsors, USA, gold sponsors, Lanka PLC, silver sponsor, Fair Energy Developers Private Limited, event sponsors, Green Building Council of Sri Lanka, Hobbs Marshall, Sri Lanka. All higher education institutes which made their submissions to the award competition, and our, most importantly, the eminent judges who did their evaluation under very short duration and difficult conditions to evaluate the submissions and deliberate their ranking to make our final decision. And finally, the board of SLEMA, who helped the organizing committee of the awards to carry out their task officially and effectively. In winding up this session and to bring this annual awards of Most Outstanding Undergraduate Energy Research 2022 to conclusion, I would take this opportunity once again to thank all who have contributed. And we strongly believe that all the participants would take their research work to the next level in their future endeavors and to contribute towards developing the domain of energy in this country and of the region at large, and towards development of a sustainable landscape to work on this domain of energy in this area. Finally, this invitation is to all our higher education institutes to contribute, encourage, and ensure the submissions of high quality for the annual awards of the Most Outstanding Undergraduate Energy Research for 2023 next year. And this is a very cordial, open invitation to participate in the next year as well. Thank you, all of you, for your attention, and have a pleasant day. The video presentation of sponsors will take place during the intermission. And thank you from me. Over to the session chair, Harsha.
Thank you very much, Professor Rahul Atalagi, for bringing forward the extremely interesting undergraduate projects to the highlight the necessary attention of the energy sector professionals in the country. So it's a great pleasure to see so many very interesting and very promising research taking place in the country, and to have that many submissions for the first occasion itself is a very great encouragement to all of us.
you.